Hey everybody, we're talking about circles today. So we did not get to the circles unit. This is would have been the next unit we did had we still been in school. So this is going to be new to you. You're going to want to seriously take notes on this one. So number one, AC and BC each equal 10. So AC and BC each equal 10. And the radius of the circle is 5. So what we've got here is two right triangles, and these are called tangent because they touch in exactly one spot and they make 90-degree angles, right? So tangents always make right triangles on the edge of the triangle. So if we're looking for the reflexive side, we're looking for this x value. We can just do 5 squared plus 10 squared equals c squared, because that is the hypotenuse, right? So 5 squared plus 10 squared is going to be 125. Square root of 125 is going to be 11.18. So this hypotenuse here is 11.18 centimeters. All right. Given AB and BC are tangent, so we could draw our same picture here. It's kind of like an ice cream cone. So I talk about this as the ice cream cone. Ice cream cones, and there's some symmetry here, right? Some symmetry. So just like we had 10 and 10, these two parts of the ice cream cone, let me erase that for a minute so we can see it a little bit better. These two parts of the ice cream cone right here are symmetrical. They are in fact equal, and they will always be equal. So we've got 10 and 10, they're equal. So x squared plus 5 equals 21. So x squared plus 5 equals 21. Anytime you see that ice cream cone, those two sides of the ice cream cone are always going to be equal to each other. So then we just solve this. Kind of looks like maybe it's going to be a hard equation, but once we subtract 5 from both sides, we get 16. We can take the square root of both sides because the inverse of squaring is square rooting. So we get x equals 4. And I think that's my answer. Now we're going to look at number 3. As soon as I get this erased. So remember, the two things to take away from this are tangents always create right triangles. And if you have two tangents, then they're always going to be equal because they're like the sides of an ice cream cone. They're going to be symmetrical. So in number 3, solve for the following. Well, what did we just learn? We learned that if BC is tangent, then this is a right angle, which means we can do Pythagorean theorem. 5 squared plus 8 squared equals c squared. We've got even a little bit more information because AD is also a radius. So it's going to be the same as AB. So AD is 5. And then we can do 5 squared plus 8 squared equals c squared. So 5 squared plus 8 squared is going to be 25 plus 64. And then we're going to take the square root in order to make the square go away. And I think AC, that whole distance, is going to end up being 9.4. 9.4, and then there's going to be some change. I'm just going to round it to that. So if I know the whole thing is 9.4, and I know this piece is the radius, that's 5, then this missing piece over here, DC, is going to be 9.4 minus 5, which is going to be 4.4. Boom. That's going to be DC. Okay, so your radius is going to be the same. Use Pythagorean theorem to find that whole distance and then subtract the whole distance from the radius or minus the radius, and that's going to give you the other piece. Going on to number 4, find the measure of OP. So my question mark is this, and I know that those are tangents, so it makes a right angle. Given OJ is 12, so the radius is 12. I don't know why that's not writing. 12, there we go. and JP is 36. So those are the two legs of my right triangle. So 12 squared plus 36 squared equals OP squared. So you can just solve that. Take the square root of it, and that's going to be your answer, right? So it's not as hard as sometimes we think, but you know, in math class, we always start off with easy examples, and then they get a little crazy. So I think we're maybe going to head towards some more difficult examples here. Question number 5. Boom. Okay, so this is a multi-part question. Before we get too excited about it, let's just read it. Circle R has a radius of 6. Okay, so I know if the radius is 6, then RQ is 6 and RS is 6, right? And then QP is tangent. So because I know it's tangent, I know this is a right angle. Okay, circle R, and then QP is 8. So what is the measure of angle RQP? RQP, oh, that's 90 degrees because tangents always give us 90-degree angles. What is the length of RP? So RP is this whole distance, and I know the two legs of my triangle, so I can do 6 squared plus 8 squared equals RP squared. You just need to solve that. So the square root of 6 squared plus 8 squared. And put that whole thing into your calculator. What is the length of RS? So RS is my other radius. So that's 6. All radii are equal or congruent. What is the length of SP? So how would you find SP? You need to find that RP from part B. So RP, you found that here. And then you subtract 6, and that's going to give you SP. All right. So you should be able to calculate all of those things. You need all of those calculations in your notes. I am not going to do them here because I'm trying to make this video a little bit shorter. But you should definitely take the time to write down all of those notes and make sure you've got them. All right, question number 6. Given point B is a point of tangent C. So what do we know because it says it's a point of tangent C? Yes, we know that's a right angle. BC and CT are both radii. Okay, so we know those are both radii. So that's R and R. AT is 8 and AB is 12. What is the diameter? All right, well, we know we can do Pythagorean theorem. So if BC is R, so that's R squared, and the other leg is 12 squared. The problem here is AC is not 8 and it's not R, it's R plus 8. And then we've got to square that. So we practice this a little bit with the right triangles. R squared plus 12 squared equals R squared plus 16R plus 64. We're going to subtract R squared from both sides. We're going to get 144. So 144 equals 16x plus 64. So 16x equals 144 minus 64. It's going to give me 80. And then 80 divided by 16, x equals 5. X equals 5. We're going to be tempted to make that our answer, but remember what was x, right? Or really r. So r was the radius. And I'm asked for the diameter. So if I know the radius is 5, what is the diameter? Diameter is 2 times that, which is 10, right? Because the diameter is all the way across, whereas the radius is only halfway across. Okay. So that's tangents, guys. That's the first new thing you need to learn in circles. Tangents create right angles. Two tangents from the same point are going to be congruent. Because they make right angles, you have right triangles, which means you can use Pythagorean theorem. Okay, so even though we have circles here, we're really just going to be using Pythagorean theorem for right triangles. So if we go to our next section, we've got a little bit more review we need to talk about first. These first two equations you should know. Area is pi r squared. Circumference is 2 pi r or pi d. Arc length. What we're doing with arc length is we're turning degrees into length. Okay, so if you think about running around a track, if I go halfway around a track, I don't say I've run 180 degrees. I say I've gone however many meters, right? The clock, if it goes from 12 o'clock to 6 o'clock, the hand has gone 180 degrees, but how far has it traveled? So we would use this arc length to change the degrees into a unit of measure. Sector area does the same thing. We're going to use that area. So maybe I have a 12-inch pizza and my son eats half of it. What area did he eat? If I have an 18-inch pizza instead of a 12-inch pizza, it's going to be a bigger area. He ate more because the pieces are bigger. So that's how we're going to do that. So you want to write down all four of these formulas. We're definitely going to use those. Central angles and their arcs are equal. So central angles mean that angle meets or has its vertex at the center of the circle. So if this is 60 degrees, this is a 60-degree angle. Okay. If this is 90 degrees, then we have a tangent, right? That's what we just learned in our last on our last page. So central angles meet at the center and the arcs and the angles are equal, and then tangents create right angles. There is another kind of angle that we can have, and it's called inscribed. So central angles meet at the center, the vertex of the angle is at the center, and inscribed angles have their vertex at the edge. So central angles, we had X and X, right? Inscribed angles, the vertex is at the edge. And so we've got small and we've got big, and the relationship is small and big. Big equals 2 times the small, or the small equals 1/2 the big. So if I've got 27, that's my small angle. I've got to double it to get 54. If I know this is half a circle, so that's 180 degrees, that means my angle is going to be 90 because 180 divided by 2 is 90. So small times 2 is big, or big divided by 2 is small. Okay. Last thing for notes. Equation of a circle. Okay, and I know this is a whole lot of information all at one time. If the center of the circle is HK, right, then in the equation, it's going to be minus H and minus K. It's almost like distance equals X minus X squared plus Y minus Y squared, right? X minus H instead of X minus X plus Y minus K instead of Y minus Y. The H and the K are the center of the circle, okay? And those signs are backwards. If H and K are positive on the circle center, then they're going to be negative in the equation. The other thing to note is this radius turns into radius squared, okay? So if you have the radical on one side, then you have just the radius on the other. If you have no radical, like in this one, then you've got to square that radius over on the other side. So r squared equals x minus h squared plus y minus k squared. We're going to keep all of those over there on the side to help us as we move forward. And again, this should have been our next unit. This is all new material. If we need to do this as a whole unit, we can talk about it as a whole unit, because I know there's going to be a lot of questions about it. All right. I think questions 1 and questions 2 are both super hard. So I think I'd like to skip those, right, and come back to them. I'm going to skip and come back. So remind me to come back to questions 1 and questions 2. This is just like on the SAT. If you get questions where you're not quite sure, they seem a little crazy, skip them and come back to them, right? We're going to, invest our time in things that we know. A circle with a diameter of 10. So automatically, if I know the diameter is 10, I know the radius is 5. Shown below, AOB is 120. So this is going to be where we want to change that degree into length, right? I want to know the length of AB, or the length of that pink line. So we're going to take our 120, we're going to divide it by 360, right? And then because we're looking for length, we want circumference. So that's 2 pi, and then we know the radius is 5. In all of our answer choices, we've got a pi. So we're not going to worry about pi right now. Okay. In your calculator, I want you to do 120 divided by 360. So 120, I'm going to do it with you. 120 divided by 360, you get 0.33. That's 1/3. Then times 2, we're going to skip over the pi for right now and multiply by 5. So you're going to get 3.3, 3.3 repeating pi. That's 3 1/3, or 10/3 pi. This equation, the angle divided by 360 times 2 pi r, is always going to give you arc length, right? If I do the angle divided by 360 times pi r squared, that's going to give you area. This is length. Can't make that any more clear. Okay. Let's look at number 4. Looks to me like I've got both a central angle and an inscribed angle. So if I know this is the central angle, then I know this is 90. And then what is the measure of CAB? I want that inscribed angle. I have the big and I want the small. And I know that the small is half the size of the big, so it must be 45, right? So the big is twice as big as the small, or the small is half as big as the big. So much information in this unit. Kills me that we weren't able to teach it and learn it face-to-face. We'll have hopefully figured out all of the video chatting by this point, and we'll be able to chat about these. Number 5, in the figure, 3 congruent circles. So I know all 3 of those circles are exactly the same. They're all tangent to each other. Have centers that lie on the diameter of a larger circle. If the area of each of these small circles is 9 pi. So area equals pi r squared. And I know that area equals 9 pi. If I divide by pi, and divide by pi, my pi's cancel out. So I get r squared equals 9. And then I take the square root, so r equals 3. Right? So the radius of each of these little circles is 3. And what is the area of the large circle? So if I know the radius of each of those circles is 3, that means this diameter is 3 of those, right? So I've got a whole diameter for this circle, that's 6. And then another radius, that's 3. So the radius of the big circle has to equal 9. Okay, so I'm looking for the area of the large circle. Area is pi r squared. So let's erase this orange part because we know that the radius of the small ones is 3. So area equals pi r squared. If r is 9 squared, that's going to be 81 pi. The circle shown has an area of 36 pi. So there's a couple different ways of thinking about this one. I've got 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8. So 36 pi, and I know 8 pieces, right? What is the perimeter of one of these regions? So I want to find the perimeter, which means I need to know the radius and the arc length. So if I know the area is 36 pi, and that equals pi r squared, if I divide by pi and take the square root, r equals 36. So I know 2 of those pieces are 6 and 6. The problem is this piece out here, that arc length. So we've got to use our arc length formula in order to figure that out. If it's divided into 3 pieces, 360 divided by 8, because each of those 3 pieces is going to be the same, 360 divided by 8 means each of those angles is 45 degrees. So each of these interior angles is 45 degrees, because 45, 45, 45, 45, 8 times is going to give me 360. So what I want to do is I want to turn that 45 divided by 360 times the circumference, 2 pi, I found the radius was 6. So 45 divided by 360, 45 divided by 360 times 2 times 6, we're going to leave out the pi again, gives me 1.5 pi. So 1.5 pi. If I add up all of those pieces, I've got 6 plus 1.5 pi. What's my answer? I've got 2 6s, so it's definitely not that. It's not 2 pi, it's 1.5 pi. So we've got our answer. Okay. This just takes some practice, and we really didn't have the practice time for it. It's important to try to remember all these formulas, make yourself some flashcards, do whatever you do to memorize things. But you definitely need to know how to turn angles into arc length and angles into sector area. We haven't practiced that yet. You need to be able to think through if you've got 8 congruent pieces, that a whole circle is 360. All of those fun things. All right, question number 7. Which of the following uses an equation of a circle? Okay, so I've got my equation of the circle over here, and I know -2 and 0. So the -2 is the x. So I know with the x, if I had hk, if I have a positive h, I have a negative h. So if I have a negative h, I need to have a positive, right? So I've got to have +2, and then 0, and then an area of 49 pi. So if the area is 49 pi, and that equals pi r squared, we get rid of our pi's, we take the square root, r equals 7, and this has got to be r, I hate it when it does that, got to be r squared, right? So it can't be a 7, it's got to be this one. This is all process of elimination. Hopefully we can get some Khan Academy practice with that. Number 8, the figure is not drawn to scale. In the figure above, ABC is inscribed, so automatically I'm thinking small and big. Small is half the size of the big, or the big is twice the size of the small. A, B, C equals 30. Okay, so this equals 30. The length of the minor arc AC is what fraction of the circumference of the circle? So if angle ABC is 30 degrees, then arc AC has to be 60 degrees. And if a whole circle is 360, what does that reduce to? How many 60-degree arcs can there be in 360 degrees? So 60 divided by 360, I think, is going to give you 1/6. You erase all this blue. Look down at number 9 while you're waiting for me to do this. Almost erased our formulas over there. All right, number 9. In the figure above, AC is a diameter. Okay. If AC is the diameter of the circle and the length of BC is 1, the radius of the circle is 1. That means this diameter is 2. I've got 1 and a 2. I should be thinking special right triangle, 30, 60, 90, which means 1, 2, square root of 3. What is the measure in degrees of BAC? Oh, special right triangle. Boom. Angle A is 30 degrees because it's across from the 1. So remember, we've got 30, 60, 90, x, 2x, x on the square root of 3. So if I have 1, 2, square root of 3, the 1 is across from the 30. So the 1 is across from the 30. In the figure above, equilateral triangle is inscribed in circle D. The area of the circle is 36 pi. So if area of the circle equals 36 pi, that's going to be pi r squared. By this point, you should just be able to say r equals 6. So if the radius equals 6, I can draw in some radii here. So all of those blue lines are 6. What is the length of the minor arc AB? So I want to know this. So how many triangles have we or how many pi wedges have we cut that into? If I use the center of the circle and I use those radii to cut that pizza, do I have 3 equal pieces? Right? So if I take the whole circle divided by 1, 2, 3 pieces, 360 divided by 3 is 120. Oh, that doesn't help me, right? What is the length of the minor arc AB? Because I've got some pi's in there. Well, let me rethink that one. So we know that. I hate it when I think I've got it and I don't. We've got 120 degrees. We've got 36 pi. Circumference. So the circumference is 2 pi r, and we know the radius. So pi 6, that's going to be 12 pi, right? That's the whole circumference, 12 pi. And then we've cut that into 1, 2, 3 pieces. So divided by 3 is going to give us a more reasonable answer as far as our answer choices. It is 120 degrees. The problem is it's not asking us in degrees, it's asking us in that length. All right, I'm glad that wasn't too hard. All right. Number 11, in the figure below, I reformatted these. In the figure below, circle C has a radius of 6 if the area of the shaded sector is 10 pi. So we know this is 10 pi. What is the measure in degrees? So the area is 10 pi. We're going to use this formula. So we want degrees. That's what we're looking for. Over 360 times the area, which we're already given. Pi r squared equals 10 pi. Equals 10 pi. So we're going to multiply by 360 on both sides. 360. So then pi r squared times our angle equals 3,600 pi. And then we can divide by pi to get rid of that. And then take the square root. So theta equals 60 degrees. Square root of 3,600 is 60. No, that is not right. I forgot that we know the radius. So theta times 6 squared equals 3,600 equals 3,600. 6 squared is 36. So pi times theta equals oh my goodness, I'm making all kinds of crazy mistakes here. Let's start this one all over again. I forgot I crossed out those pi's. My algebra is going crazy. I must be getting tired making videos. All right, let's try this again. Theta over 360 times pi r squared, I know that's 6 squared, equals 10 pi. Okay, I've got pi on both sides, so I can cross those out. I can multiply both sides by 360 to cross them out here. So then 36 pi, because that's 6 squared times theta, because I crossed out my pi. 36 theta equals 3,600. Divide by 36, and theta equals 100 degrees. Okay, theta equals 100 degrees. So that is going to be our answer, 100 degrees. We'll find more practice with that because that was very confusing. In fact, maybe our more practice is going to come right here. In the figure above, the circle has a center of O and a radius of 5. The measure between the central angle is between 45 and 90. What is one possible integer value of the length? Okay. So we're going to have to do this equation, but we're going to have to do it twice. Once with a 45 and once with a 90. So if it's the 45 divided by 360 times 2 pi times 5. So 45. So 45 divided by 360 times 2 times pi times 5. I think it's going to give me 3.926, right? So we need something bigger than that, right? Arc BC. And then if I use, instead of the 45, I use the 90. 90 divided by 360 times 2 pi 5. We're going to do all that multiplication, and we get 7.85. What is a possible integer value? So integers are positive or negative whole numbers. If we're talking about geometry, we need positive numbers. So it could be 4, it could be 5, it could be 6, or it could be 7. But it's got to be bigger than 3.9 and smaller than 7.8. Okay. Erase, erase, erase. As I'm doing these, I'm certain we're going to need to do some more practice with these, so I'll have to figure something out for us. Definitely not the most important skill, though. Really, most questions are going to come from triangles. The base of a right cylinder shown below has a radius of 4. So R equals 4. The height is 5. The height is 5. Oh, this is a surface area and volume question. What is the surface area of the cylinder? So this actually should not be here, but surface area equals the top and the bottom. So the top is going to be pi r squared, which is 4 squared. And we need 2 of them, one for the top and one for the bottom. And then plus 2 pi r, that's the circumference, r, times the height, which is 5. So if you do that, pi times 4 squared, 16, that's 32 pi, plus 40 pi should give you 72 pi. Okay, this should be on your formula sheet. This actually should not be in this series of questions, but it's good because you do need surface, or you need circumference and area for the surface area and volume formula. So surface area, let's just write the formula, is 2 times the area, which is pi r squared, and then plus the circumference, which is 2 pi r times the height, right? That's the surface area. So you use the area, that's the top and the bottom. And then you use the circumference because that's the length times the width, length times the width, right? The length, width. Okay. That's probably more important for me to talk through than for you to listen through. You can fast forward that part, hopefully. Maybe you did. All right. Question number 14 is a fun question, I think. In the figure shown, 4 circles, each with a radius of 4. So you wouldn't really know to do this, but if the radius is 4, then we can connect all those radii to make a square, right? All those radii are 4, so now the square is 8 by 8, and they're tangent to each other. What is the area of the shaded region? So if I've got 1, 2, 3, 4 quarters of a circle, that makes a whole circle, right? And I can do the area of the circle. All 4 of those parts make one circle. It's just going to be pi times 4 squared, or 16 pi. Then I can do the area of the square. Area of the square. I feel like the stylus is getting worse and worse the more I use it. That's going to be 8 times 8, which is 64. So then the shaded part is going to be that whole blue square minus the white circle made by those 4 quarters of a circle. So 64 minus 16 pi. Boom. Takes a long time to work that problem to see that that's what you have to do, but that is the most efficient part. And this kind of problem is pretty frequently seen. You need to see kind of the part minus the total minus the part leaves you the other part. So somehow you need to try to find a total and a part in order to give you what you want. And they just take a lot of practice. Question 15 and 16 are going to be similar. Okay, we're going to have to find different ways to break down these pictures. So in the figure shown, circle P and circle U have a radius of 3. So I know this is 3, and this is 3, and this is 3, and this is 3. Their tangent, PHU, is an equilateral triangle, which means this is also 3, and this is also 3, because they're all going to be 6, right? What is the area of the shaded region? So lots of different ways to do this. The way I like to do this is if I slice these circles up like pizzas, because I think of all circles as pizzas, right? How many pieces of pizza do I have? I have 1, 2, 3, 4, 5 on the left, and 1, 2, 3, 4, 5 on the right. So I have a total of 10 pizzas, and each piece is 1/6 of the circle, right? So I have 10/6 of a circle, and I know the radius. So can I find the area? I think so. Each of those pieces is going to be 60 degrees. So 60 divided by 360. And then times the area, pi times 3 squared. If I multiply all that together, I should get my answer. Okay, so I'm giving you some time to do that. 10 divided by 6. Oh, wait a minute. I don't need this divided by 6 because that is the 60 over 360, right? So 10/6 pi r squared. So we're just going to do that. 10 times 60 divided by 360 times 3 squared should leave us with 15 pi, right? 600 divided by 360 times 9 is going to give me 15. Number 16 is going to be the same idea. Note the figure is not drawn to scale. If the area of the shaded region is 24 pi, and the radius of circle O is 6, the stylus, ay caramba, is 6 and 6. What is the value of x? So with this area, I can find my angle. So x over 360 times pi 6 squared equals 24 pi. The pi's cancel out because I have a pi on the left and a pi on the right. If I multiply by 360, I get 36x equals 24 times 360. 24 times 360 is 8640. And then divided by 36. X equals 240. So if this gray part is 240, that means this part has got to be 120. 120, so 180 minus 120 divided by 2. I think each of those is going to end up being 30. Okay. Boom, 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 boom. So many ways to divide these up. I'm sure there are other ways to do these. This is just the way my brain sees them. I'm happy to talk about these in the chat. I wonder whether by this point we'll be using Zoom still, or whether we'll have transitioned over to Google Hangouts or even something else that I haven't even discovered yet. Boop, 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 boop. All right. Question 16 down. Question 17. The equation of the circle in the xy plane, which of the following must be true? Okay. So we're looking at our equation here. So I know h and k has to be -2. Remember, our h and our k have to be opposite. So if I have a +2 in the equation, I have a -2. And then if I have a +4, I have a -4. And then my radius is 2. So the center of the circle, that is not correct because I know my signs have to be opposite. I would say go to Desmos here, but you won't have Desmos on the SAT. So you can sketch out a graph. If I know my center is at -2, and then -1, 2, 3, 4, that's my circle center. My radius is 2. That means I can put a dot there, and a dot there, and a dot there, and a dot there. And then I draw my circle. The circle is tangent to the y-axis. So the y-axis. And I think that's the only answer. So boom. In the figure below, circle A is tangent to circle B at point D. So we know this is a right angle, which each circle has a radius of 4. So this is 4, and this whole thing is 8. So automatically I'm thinking 30, 60, 90. So 30, 60, 90. This is 4 on the square root of 3. That side right there. What is the area of the triangle ABC? So we want to do 1/2 base times height. The trick here is to think about what this height is. If you didn't recognize it as a 30, 60, 90, you could do Pythagorean theorem. 8 squared plus 4 squared is going to give you whatever the decimal is for 4 on the square root of 3. That's going to work as well. So then we're going to do 1/2 base, which is 4, times the height, which is 4 on the square root of 3. When you put all of that into the calculator, you should get your answer. Oh, wait, did I do something wrong? AC is tangent to B at point C. What is the area? I didn't do anything wrong here. What I did wrong was on my answer key. This is 8. This is 4 square root of 3, square root of 3. All right. Let's erase all of this. Boom, 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 boom. There's even more in the circle unit that we would have learned had we been in school. So be thankful that it's just these few things that we're talking about here today. All right, 19. So we've seen these problems before in the right triangles unit. So the last two shouldn't be too difficult. Again, we need to think about those special right triangles. So in number 19, I'm going to draw this a little bit bigger. Don't have a lot of room to draw it bigger. I've got this down here. So essentially, in order to get to this point, if I draw in that slope triangle, I've gone square root of 3 and 1, which means this radius is 2, which means this angle right here is a 30-degree angle. So beta is 30 degrees, which means the whole rest of this circle, and again, this is math analysis, this is the unit circle, is going to be 330 degrees. Okay. And question number 20, if I know BD is 2, right? This is a 45, 45, 90 triangle. So in my 45, 45, 90 triangle, I have x, x, x on the square root of 2. If I know that x on the square root of 2 equals 2, then I can divide by the square root of 2, divide by the square root of 2, rationalize my denominator. 2 on the square root of 2 divided by 2, and those cancel out, which means the height of my square is the square root of 2. I'm going to erase some of this just so I have a little bit more room. You can always go back if you need all that information. So then what is my question? The area of a circle. So ultimately I need to find the radius. So if I cut this, right, each of those radii are going to be half of this side length. So this square root of 2 divided by 2 equals the radius. In order to find the area of a circle equals pi r squared. So pi times square root of 2 over 2 squared. When you do that, you've got to kind of think about distributing that 2. So we've got pi, or that squared sign. Square root of 2 squared is 2, and 2 squared is 4, which reduces to 1/2, or pi over 2, right? 1/2 pi. Boom. And that's it, ladies and gentlemen. That is circles. Remember, central angles, the angle equals the arc. Inscribed angles, you've got a small angle and a big arc. In the circle equation, H and K, the signs are backwards. If one of them is positive, then the other is going to be negative, and the r squared, right? And then the angle over 360 times the circumference will give you length, and angle over 360 times the area will give you the area. All right, guys, that's it. I'll see you in the conferences.